Cisco Certified Network Associate Day 2. This is Imran Rafai, your trainer for this entire series. Welcome back everybody for the second day in our training series. As you already know, this is a free training on YouTube for all the people who are interested to start a career in networking. In our last video, we learned about network fundamentals. Today, we would be dealing with the OSI reference model and TCP/IP model. When I say TCP/IP model or OSI model, it is nothing but a set of rules. It's a set of standards. Now you might ask, why do we need a set of rules or set of standards in the computer industry? To understand that, we need to learn a little bit about the history of the computer industry. Not long ago, there was a fierce battle between IBM and Digital Equipment Corporation to become the leading computer manufacturer. But there was a problem. Both these manufacturers manufactured devices which were not compatible with each other. So if you bought a computer from IBM, you had to buy a monitor and printer and everything from IBM. Similarly, if you bought a device from Digital Equipment Corporation, then you had to buy all the accessories and all the other devices from Digital Equipment Corporation so that you can actually use it. There were many companies which bought equipment from both the equipment manufacturer, such that the accounts department had IBM computers and devices and the marketing department had Digital Equipment Corporation computer. But the problem is they could not communicate with each other, or they could not even share information with each other. Now that was not the right way forward. That was about the time when International Organization for Standards, or more commonly known as ISO, thought that there was a need for a standard. ISO developed OSI, which is an acronym for Open System Interconnect, which is more commonly known as the OSI reference model. At about the same time, a competing standard known as the TCP/IP model, which was promoted by the Department of Defense, came into being. The TCP/IP model is more like a stripped down version of the OSI model, and because it was more relevant, it went on to become the industry standard. To understand a little bit more about the models, we need to understand about layered approaches. To understand that, let's talk about this office that you see on the screen. Every office has different employees and employee levels. So you might have a CEO, you might have senior office staff, you might have payroll manager, an account manager, maintenance manager, you have maintenance staff, you have junior office staff, and you have different staff. The reason every companies have different employees with different designation is because all those people have different roles and responsibilities. So when you know that something is not done or some task is not accomplished, you know who is responsible. For instance, if your salary is not credited on time, you know the responsibility has to be with the payroll manager. Whether the bank is involved or that's secondary, but the payroll is your first point of contact. You will need to go and speak to the payroll manager. If you come to office one fine day and you see your office really dirty, it's not cleaned, you know the janitor is responsible or the maintenance department is responsible. So you know where the responsibility lies. Similarly, we learn about the OSI model and the TCP/IP model because in learning about the computer networks, or tomorrow when we are troubleshooting computer networks, we need to know what works at what layer. So if something isn't working, instead of troubleshooting all the equipments, we know exactly where the problem is. That is why we have a layered approach. Alright, knowing what we know now, let's get into the models. Let's understand how models work, what are the layers involved, and let's compare TCP/IP and the OSI model. What you see on the left is the OSI model. What you see on your right is the TCP/IP model. Let me take a highlighter so that I can highlight as I talk. Alright, for the moment, don't worry about the colors. I have color coded it to compare between the OSI model and the TCP/IP model. So let's start discussing from the left, from OSI model. Before we go any further, I need to stress on this point that As a student of networking, all of you should know the layers by heart. So when I say that, you need to know exactly the sequences of the layer. You need to know layer 7 is application layer, layer 1 is physical layer, layer 5 is session layer. You just need to know where the layers are. One way of remembering the sequences of this layer is by having mnemonics. One of the most popular mnemonics to remember the OSI reference model is the one given here. So if you remember, please do not throw sausage pizza away. You can remember the first letter of the layers from bottom up. So please do not throw sausage pizza away is PDNTSPA. Similarly, some people would want to remember the layers from top to bottom, which is perfectly fine. So if you want to remember it from top to bottom, then you have another mnemonics which says all people seem to need data processing. Well, it's up to you. You can do it the way you like it, as long as you remember that physical layer is layer 1 and application layer is layer 7. Some people get confused when they remember it from top to bottom that application is layer 1. No, application is layer 7, physical is layer 1. All right, and if you want to remember TCP IP model, then you could remember by just remembering this mnemonics, which is TCP IP comes in a tin. Well, it doesn't mean anything, but you can just remember a tin, that is application, transport, internet and network interface. Like I said, if you have a better way of remembering, please use it. As long as you remember the sequence of these layers, it should be perfectly fine. All right, let's start with the application layer. Application layer is the point of contact for all network aware application. Let me repeat that. It's a point of contact for all network aware applications. A lot of authors, I have heard them say that all the applications on your computer resides on this application layer, which is not true. Application layer 1 deals with only applications that is network aware, and all the applications on your computer has nothing to do with the application layer if they do not communicate on the network. To understand that a little bit more, let's assume that you have uninstalled all the drivers on your PC, your wireless network interface card and your Ethernet card, all the network interface card you uninstall from you uninstall the drivers. You can even physically remove if you can. Now if you fire up Microsoft Word, for instance, Microsoft Word will not communicate with the application layer, or for that matter it will not communicate with any of this layer. That is because Microsoft cannot access your network because it does not have your operating system does not even have a network interface card. Similarly, on a normal system, if you fire up your web browser, maybe Chrome, Internet Explorer, Safari or any of the web browsers, and if you type www.cnn.com, that web browser creates an HTTP request. It communicates with your application layer. The application layer gives that data to the presentation layer. The presentation layer does what it has to do, gives it to the sessions layer. Sessions layer does a similar thing. It gives to transport, and it keeps passing it to the next layer until it reaches the physical layer. So this is how it works. So if an application communicates with the network, that's the only time application layer is invoked. Some of the protocols that work on this layer are FTP, TFTP, SNMP, DNS, HTTP, and there are quite a few. So you can just do Google, you will get the entire list of all the protocols that work at this layer. Next we'll deal with the presentation layer. The presentation layer is the layer which generifies data. When I say generifies data, it's a layer which takes the data coming from sessions layer on the way back, converts it to presentable form and gives it to the application layer. So if you have raw data coming from sessions layer to the presentation layer, this is where data is converted. So if it's an image, it creates an image. If it's a Word document, it creates a Word document. So presentation layer is where all the data conversion happens. Also, all encryption services like TLS, SSL, all that are taken care at this layer. Next, we have the sessions layer. Sessions layer is the layer which creates and maintains session. When I say that, let's assume your computer has two applications. You have your telnet program and you have your web browsing application, maybe Internet Explorer. Now both of these applications are accessing the network. So this layer is which creates two separate sessions and maintains them. So when your web browser session is terminated, your telnet session also will not get terminated because they are separate sessions. So it maintains different sessions. Now I've color coded the top three layers in blue, and the reason I have done that is because as a network engineer, and especially as a Cisco network engineer, there's very little that we need to deal with layer 5, 6 and 7. That is because most of the Cisco devices will not look beyond layer 4. So layer 1, 2, 3 and 4 are very critical for a Cisco engineer, but 5, 6 and 7 are not so critical. You just need to know how it works, and you know, as a rough idea, you know what it does. That should be perfectly fine, because layer 5, 6, 7 are taken care of by the operating system. But layer 4, 3, 2, 1 is where, as a network engineer, you have to know exactly how that works. Right. Next, we learn about the transport layer. Transport layer is also one of the critical layers for a network engineer. When the information coming from the upper layers comes to the transport layer breaks them into manageable segments. Each segment, transport layer adds its own header to create an encapsulation. Two critical decisions the transport layer takes is one, whether to have reliable communication or unreliable communication. Second is to create a port number. When applications need a reliable communication, transport layer uses TCP, which is nothing but an acronym for Transmission Control Protocol. If it wants an unreliable communication, it uses UDP, which is nothing but an acronym for User Datagram Protocol. When I say reliable, it doesn't mean it is better than unreliable, in that the only difference is reliable communication has to get an acknowledgement for every packet that is sent. In unreliable, there is no acknowledgement that is received for every segment transmission. So unreliable is actually faster because of the less overhead. So if it is real-time applications will use UDP because it is faster and it is real-time. So most of the time, if you have tried watching an online transmission or a live feed, there are times when we see those green pixels on the screen. This is nothing but the information for that pixel had not received, and the receiving device had no way to tell the sending device that it had not received that pixel. Similarly, another function that is taken care of by the transport layer is to create port numbers. Port number is a number that is attached with the IP address to identify which application this information is coming from. So the transport layer creates a random source port number, and then it attaches the port number for the destination. So if your traffic is going to a web server has a standard port number of 80. So if you're going to an IP address 10.10.10.10, for instance, just an example, at transport layer it takes 10.10.10 and it adds a port number of 80. So it creates a socket. Socket is nothing but an IP address and port number. It creates socket and it sends down to the network layer. It also adds a source port number. Why does it require source port number? The reason it creates a source port number is Because if there are two applications running on your computer and it is going to the same IP address, when the reply comes back, transport layer needs to know which data goes to which application, and it will identify that by actually having your source port numbers. Next, we learn about the network layer. When the network layer gets a segment from the transport layer, it adds a network layer header. When a network layer header is added, that information is called as a packet. So one of the critical functions of the network layer is of IP addressing, or also known as logical addressing. We will learn about IP addressing in the next video, day 3, but just know that this is where IP address is added. It also finds the best path. So when I say best path, it compares the IP addresses and it checks if the destination IP address is in the local subnet. If it is not on the local subnet, it will find the best path to go to the destination. Next, we have the data link layer. When the packet comes from the network layer down to the data link layer will add a data link header to it, and that information is called as a frame. The data link layer is responsible for MAC addressing. MAC is nothing but an acronym for Media Access Controller, and MAC address is a hardware address. That means every network interface card of your computer has its own MAC address. MAC address is also known as burnt-in address, and it's an address that cannot be changed. Yes, there are ways of spoofing the address, but it cannot be changed physically. This is also a layer where error checking happens. So when information coming from the physical layer to the data link layer, the data link layer has the ability to check if there were errors that was induced during transmission. So it could use a cyclic redundancy check, CRC, or it could use parity check, and there are other error checking mechanisms that data link layer uses to check for errors. Next is the physical layer, and physical layer is where the actual data transfer happens. This is the layer which deals with wires and cables and your hardware ports and hardware connectors. All those things happen at this layer. So as a computer engineer or as a network engineer, when somebody tells you that the internet does not work, as an engineer you will start working or troubleshooting from physical layer. First you will check the cables to see if it works. If the cables are fine, next you will check for your layer 2 problem. Then you'll go to layer 3, layer 4. So you'll troubleshoot by layers. And that is why we have to learn about the models. Also, any change in one of the layers will not affect the adjacent layer as long as the standard is followed. So if for physical layer, instead of Ethernet cable, I choose to use wireless, it should not matter because the change happening on the physical layer only. So data link layer, as long as it gets information the way it is expecting it to get, it does not matter how physical layer gets those information. Similarly, the network layer, I mean, we are in the transition phase of going from IPv4 to IPv6. So that change is only to layer 3. Layer 4 and layer 2 will not get affected as long as the standard is followed and it receives the data information the way it was expecting it to receive earlier. So that is the beauty of the layered approach. Now if you compare the left and the right, we can see that layer 5, 6 and 7 is comparable to layer 4 of the TCP IP model. Transport layer and transport layer of TCP, they have comparable functions. Similarly, the network layer and the internet layer. The layer 1 and layer 2 of OSI model is comparable to layer 1 of the TCP IP model. Next, we will just see the OSI model working. Let's assume the guy on the left wants to send something to the guy on the right. So he creates a data. Like we mentioned, the top 3 layers are generally known as the upper layers, and upper layer we really don't deal much. So let's assume the data goes to the transport layer. What the transport layer does is it takes the data, it segments it, and adds its own header. So you see you have a transport header here and you have a transport header here. Next, let's assume we are dealing with UDP here, so it is not waiting for acknowledgement, so it will send segment 1 to the network layer. The network layer, as we know, will add a network header to it and it becomes a packet now. Now network layer will give segment 1 or the packet to the data link layer. So data link layer takes that and adds a data link header. And if you can see, segment 2 also goes through the same process. Next, the segment 1 goes to the physical link layer, and the physical link layer, as we know, will convert it into zeros and 1. So our segment 1 got converted. Next, segment 2 also will get converted. By that time, the physical layer of the destination device would have taken those physical bits or physical layer bits and converted it into segment with the appropriate headers. What the receiving layers will do is it will strip the headers of the corresponding layers from the source. So data link layer will remove the data link header and give that information to the network layer. So if you see, there was a data link header to segment 1 which the data link layer stripped and gave that information to network layer. Similarly, it will happen to segment 2 as well. So for segment 1, when it goes to transport layer, this network header will get removed. So if you see there, the network header got removed and it reached the transport layer. Next, the transport layer will wait until it gets all the segment. That's what the transport layer will do. So transport layer waits until segment 2 comes there. Now transport layer will strip all the transport layer headers and combine that information and give it to the upper layers. So that transport layer combines it and it is given, and the receiving guy receives the same data. And this is how a very basic representation of how a data network works. I think that's about all the information that we had to learn in this day 2 video series. Please go through this entire cloud map and I'm sure you understand all the topics here, but if you do not, please feel free to write into me at imran.rafai@nwking.org. Please don't forget to share our videos, like our videos, and please subscribe to our YouTube channel. Your love and your respect is what motivates us to create free content. Thank you so much.